Now let's continue from where we stopped at in the previous video. So we were at the functional group of alcohol. I mentioned that alcohols undergo reactions that are typical of OH group with sodium, because you know that sodium is a test for OH group. Sodium reacts with alcohols, carboxylic acids, and phenols. Anything that has OH group will react with sodium. Okay, but if you were to write down in the deduction table, please list down the three functional groups properly. So this is what happens, and I mentioned that one alcohol, one ROH will react to give half hydrogen gas. Okay, let's continue and look at what happens next. What other reactions do alcohols undergo? Okay, if the alcohol has a CH3H and OH group, I'm going to highlight here, meaning that if you have this functional group, which is the same as this one, okay, it will undergo the trialdehyde reaction with alkaline aqueous aldene. Please take note that this atom must be either a H or carbon. In this case, this atom is a H. Now let's look at what happens in this reaction. This reaction is a way to decrease by one carbon. So the methyl groups get cut off, and this methyl group that's cut off will become CHI3, the yellow PPT. And what happens to this remaining carbon here? It becomes oxidized to the salt of a carboxylic acid. This is an oxidation reaction. So you may be wondering, okay, so this is a way to cut by one carbon, so this bond breaks. These methyl groups get cut off to become the yellow PPT, CHI3. The remaining carbon here is oxidized to carboxylic acid, but it's a salt because of the alkaline medium. Okay? So this trialdehyde reaction is for any alcohol with this functional group. And later on, you will also recap that it is also for any aldehyde or ketone with this functional group that satisfies this box is also carbon or hydrogen. Okay? So let's move on. Okay, what other reactions do alcohols undergo? Okay, in fact, alcohols can react with carboxylic acids to form esters. Alcohols can also react with acyl chloride to form esters. Okay, but I think it will be neater if I talk about that under carboxylic acids and derivatives. So I'm just going to move on to other types of reactions. I will cover that later when I go to carboxylic acids and derivatives. Okay, so one very important reaction alcohols undergo is what? You should know is oxidation. Okay, primary, secondary, tertiary alcohols which undergo oxidation. You should know is only primary or secondary alcohol. Tertiary alcohol do not undergo oxidation. Let's take a look at this particular alcohol here. Okay. Now this particular alcohol is a primary alcohol. Primary means that there is only one alkyl group bonded to the carbon with OH. A primary alcohol can undergo controlled oxidation to give us an aldehyde. It's no change in carbon number. Okay, it's just an aldehyde. What is the reagent and condition for this? For this oxidation, the controlled oxidation. You have to use the weaker oxidizing agent dichromate, dilute sulfuric acid, distill. Please take note. Only upon distillation we get the aldehyde. Why must distill? Because if I don't distill the primary alcohol, if I don't distill the aldehyde out, what will happen is that the aldehyde will be in contact with the dichromate oxidizing agent, and aldehydes can be oxidized very easily to the carboxylic acids. So if I want to protect the aldehyde and prevent it from getting oxidized further, there's a need to distill out the aldehyde immediately once it's formed. So in some textbooks you see that they say immediate distillation. Okay? Okay, so we get the aldehyde here. Okay, so what if look at the oxidizing agent. Can we use manganate if we want to get the aldehyde? The answer is no, because manganate will oxidize the primary alcohol too vigorously. Is too strong an oxidizing agent. Manganate will oxidize it to an carboxylic acid. Okay, so the only way to get an aldehyde is this condition. So please remember this. Okay, so if we want to get a carboxylic acid from primary alcohol, what do? We just heat. Okay, we just heat. We don't distill. We just heat with either KMNO4 with sulfuric acid aqueous, or we can also use dichromate aqueous sulfuric acid heat. Please have the aqueous state symbol so that it's dissociated the ions. So this is the different ways of oxidizing a primary alcohol. Of course, if you have a secondary alcohol, right, you will get a ketone. Okay, the secondary alcohol is oxidized to a ketone. Okay, so I'll leave you to recap on your own how a secondary alcohol is oxidized to a ketone. Look at your notes. Okay, so now, the primary alcohol can be oxidized, control oxidation to an aldehyde. An aldehyde or ketone, they are both carbonyl compounds. So an aldehyde can undergo what type of main reaction? Okay, it is nucleophilic addition. Why? Because again, the aldehyde is a delta plus carbon. The delta plus carbon of an aldehyde is going to attract nucleophile. Again, what is a nucleophile? A nucleophile is something that likes nucleus, that's positive. So a nucleophile is either negative charge or delta negative charge with a lone pair of electrons. So an example will be Cn minus the lone pair. So this is what happens. HCN with trace KCN 10 to 20 degrees Celsius. You're going to get nucleophilic addition to occur. So I'm going to write out what is going to happen exactly. So your pi bond is going to break. And what happens next is that your HCN is going to add across the double bond. Okay, like this. The H will go to the O, the CN will go to the C of the CO group. Okay, so because of delta plus carbon in the aldehyde is going to attract nucleophile, and because the C double bond O is unsaturated, so addition occurs. Look at the mechanism nucleophilic addition. Okay, to understand how the nucleophile attacks. The trace KCN, the potassium cyanide or sodium cyanide is a catalyst, so I only need a little bit because the catalyst is regenerated. Besides KCN, we can also use sodium cyanide as the trace sodium cyanide as catalyst. I want to point out that this is a very important reaction to increase by 1 carbon. Okay, so do not confuse this with halogenate alkane plus KCN in ethanol heat. That is nucleophilic substitution of a halogenate alkane with potassium cyanide. Okay, don't be confused between these two. Okay, so now I'm going to erase off this. We are going to look at what other reactions an aldehyde can undergo besides nucleophilic addition. How does this condensation come about? Okay, so 2,4-DNPH, I have written in short form here, but please spell it out in full. It is 2,4-dinitro phenylhydrazine. And let's look at the structure. Hydrazine has this structure like this. NH2, NH2. Okay? And if I want to talk about phenylhydrazine, when it's phenyl, it means that it's saying that it is talking about benzene as a prefix. So this is phenylhydrazine. 2,4-dinitro, so 1, 2, that means 2 nitro, 4 nitro. Okay, so this is hydrazine. Okay, and then for this aldehyde, okay, so this is what happens. And the condensation takes place over here like this. The 2H and the O come out. You lose a water and you get this product. This C will bond to this N via a double bond. This is what happens. This C to this N via a double bond. And we get an orange PPT. Do you need to know how to draw the structure of 2,4-dinitrophenylhydrazine? Yes. You can derive it from the name on the spot. Okay, so let's continue. What other types of reactions does an aldehyde undergo? Okay, because over here I don't have a secondary alcohol, but just now I mentioned that a secondary alcohol is oxidized to a ketone, right? So what is the main difference between these two types of carbonyl compounds, between an aldehyde and a ketone? You should know that aldehydes can be oxidized further to carboxylic acid. So in fact, if I want, maybe I should just write it this way. So if I want to oxidize an aldehyde to a carboxylic acid, simply used either potassium dichromate or potassium manganate with sulfuric acid equals heat. It's either or. You don't use both. Okay? Either potassium manganate or potassium dichromate. Okay, so What other oxidizing agents are there? Okay, we can have Tollens reagent and Fillings reagent. They are all mild oxidizing agents that can react with the aldehydes. So, but the difference is that although they are oxidizing agent, they will oxidize the aldehyde to the salt of a carboxylic acid because they are both alkaline medium oxidizing agent. Okay, so you can either use Tollens reagent warm or you can use Filling solution warm. Filling solution contains copper 2+ and sodium hydroxide and tartrate ions. Okay, so you should know that the observation for Tollens reagent is silver mirror, and for filling solution is also a brick weak precipitate of copper 1 oxide. Okay, over here I have a bit of a difficulty because I'm trying to connect this aldehyde to this side over here. Okay, what I want to stress is that the aldehyde test can also work for some of you will call it a methyl ketone group or methyl carbonyl group, but I prefer you to write down that it is actually a CH3 bonded to a CO, and this group is either a carbon or H. So it can also undergo trialdehyde, and it'll give me these products over here. So if I really want, I can do this. Okay, we will get iodine aqueous warm with sodium hydroxide. You're going to cut off the methyl group. The methyl group becomes CHI3, and then the remaining part becomes oxidized to a HCOO-. Okay, the salt of a carboxylic acid. And this way will also decrease by 1 carbon. And the reason why it can undergo this is because it has this functional group here. A CH3 bonded to a C double bond O, provided that this atom is actually a carbon or hydrogen. Okay, so I'll pause here for a short while, but I need to erase this because I need space for other reactions. Okay, so it doesn't mean that all aldehydes or ketones undergo trialdehyde. It's only aldehydes and ketones that have this functional group. They can undergo trialdehyde. Okay, one more reaction that aldehydes can undergo, okay, or carbonyl compounds in general can undergo is reduction. Meaning that I can reduce my aldehyde to the primary alcohol. I can either use hydrogen with nickel heat, or I can use lithium aluminum hydride in dry ether, or I can even use sodium boron hydride in methanol. I want to stress that sodium boron hydride in methanol is only to reduce aldehyde and ketones only. So how does this reduction occur? It's simply you break the pi bond and you add the HH across, and then you get back the alcohol. That's how you can recognize the pattern, the reduction. Just break the pi bond, add the HH across, I can get the alcohol. Now I only have 2 minutes left for this video, so I don't think I can finish talking about carboxylic acids and derivatives, but nonetheless I want to just connect this part here to show you how a carboxylic acid can be converted to its derivatives. So carboxylic acids can be converted into its derivatives. The easiest one would be acyl chloride. Okay, but before I go on, right, I want to stress that carboxylic acids and derivatives, they undergo what type of reaction? Delta plus carbon, right? So it attracts nucleophile. And because of the leaving group possible, it is actually a nucleophilic acyl substitution or condensation. Okay, so so if we want to convert to an acyl chloride, what do we do? How to convert OH to Cl? Simply PCl5 at solid state at RTP. How do we form an ester? If we want to form this ester here, we will have to use methanol with the carboxylic acid, consulfuric acid heat. Strictly speaking, it's actually a reversible arrow. Okay, the consulfuric acid will absorb the water and push the equilibrium to the right. Okay, then we have the how to form an amide. Okay, now I hope you will not do this, because carboxylic acid and ammonia will give me an acid-base reaction. Because carboxylic acid is acidic, you will lose a H plus to the ammonia, they will accept H plus to become NH4 plus. So the only way is to use acyl chloride to react with ammonia gas. And we can get the amide. If I want to form the ester, acyl chloride is super reactive, just react with the alcohol at RTP. So among all the carboxylic acid and derivatives, acyl chloride is the most reactive, and it can undergo condensation or nucleophilic acyl sub the most readily. at room temperature, as you can see here.